One.
All right. This is problem 6 on the 2017 AP Statistics exam on the free response portion. My screen's freezing up. Give me 1 second. All right. Read this carefully. It did trip some people up, and you're probably going to have to read it more than once. So, consider an experiment in which 2 men and 2 women will be randomly assigned to either a treatment group or a control group in such a way that each group has 2 people. The people are identified basically as man 1, man 2, woman 1, and woman 2. The 6 possible arrangements are below, where man 1 is in the treatment group, man 2 is in the treatment group, woman 1 is in the control group, woman 2 is in the control group, is arrangement A. Arrangement B, another possibility, is man 1 is in treatment, woman 1 is in treatment, man 2 is in control, woman 2 is in control group. Keep going through that, read through it, down to 2 possible methods of assignment are being considered. The sequential coin flip method, as described in A, which is here, and the chip method, as described in B on the next page. For each method, the order of assignment will be man 1, man 2, woman 1, woman 2. Right here, this is critical, and if you're not reading clearly, then I think you're going to struggle with the problem. So, for the sequential coin flip method, a fair coin is flipped until one group has 2 people. An outcome of tails puts the person in the treatment group, and an outcome of heads assigns the person to the control group. As soon as one group has 2 people, the remaining people are automatically assigned to the other group. Complete the table below by calculating the probability of each arrangement occurring. So that means arrangement A, man 1, man 2. Remember, we have the order right here. So that first person, it goes man 1. And what is the probability of man 1 being assigned to treatment? It's a coin flip. It should just be 1/2. Man 1, done. On to man 2. What's the probability that man 2 is assigned to the treatment group? Well, there's still a spot in the treatment group, so that's just 1/2 again. After that, woman 1 and woman 2 are going to be assigned to the control group because the treatment group is already full. So the probability of arrangement A happening is 1/2 times 1/2, or 1/4. Start over. Arrangement B, starting with man 1, what is the probability man 1 is put in the treatment group? It's just a coin flip, 1/2. Now, what's the probability that man 2 is assigned to the control group? Also 1/2. But unlike arrangement A, neither the treatment group or the control group is full, so we move on to woman 1. What's the probability woman 1 is in the treatment group? Well, it's just 1/2, it's a coin flip. But now treatment group is full, so woman 2 is automatically assigned. Or 1/2 to the third here is going to be 1/8. So moving on, starting over again, man 1 in arrangement C, 1/2. Man 2 into the control group is 1/2. Woman 1 gets assigned to the control group as 1/2 again, but just like before, but with the control group is full, and woman 2 is automatically going to be assigned to the treatment. 1/2 to the third is 1/8. Arrangement D, starting with man 1 to the control group, is 1/2. It's a coin flip. Man 2 to the control group, it's a coin flip, but now control group is full. That means woman 1 and woman 2 are going to automatically be assigned to the treatment group, and that's 1/4. Why don't you pause and try for arrangement E and arrangement F on your own? Hopefully you got it to be like B and C, where it's 1/2, 1/2, 1/2, and E should be 1/8, and F should be the same. 1/2 to the third is 1/8. So arrangement A should be a fourth. I'm sorry, arrangement A and D should be 1/4. Arrangements B, C, E, F should be 1/8. So the actual question, or that was AI. For the sequential coin flip method, what is the probability that man 1 and man 2 are assigned to the same group? 2 out of 2 out of 6, or 1/3. All right, please ignore what I just said. I called that one wrong. When I said 2 out of 6, I was assuming that all of these are equally likely. They're not. We actually just spent all that time proving that they're not. So when it says what's the probability that man 1 and man 2 are assigned to the same group, means what's the probability of A happening plus the probability of D happening. Well, that's 1/4 and 1/4, or 1/2. And I won't change my story on that one. So B, for the chip method, 2 chips are marked. 2 chips are marked treatment and 2 chips are marked control. Essentially, this is like drawing pieces of paper that say treatment and pieces of paper that say control. Each person selects 1 chip at random without replacement, which is key here. We're still going in the order man 1, man 2, woman 1, woman 2. So this time, man 1 draws the treatment. We'll start 2 out of 4 were marked treatment. I know that's 1/2, but let's just keep it basic for probability. So now when man 2 is up, he draws 1 and he gets assigned to treatment. But when he draws it, that first treatment chip is no longer in it. So there was only 1 treatment chip left out of the 3 that he had to choose from. So this would be 2 over 12, or 1/6. Moving on to arrangement B. Man 1 draws treatment, 2 out of 4, 1/2. Now man 2 draws control. There were 2 controls left, and then there were 3 that he chose from. Moving on to woman 1, there was only 1 treatment left out of the 2 she had to choose from. It doesn't matter. Woman 2 is only left with 1 more choice, so we don't have to multiply it. And B should be 2 times 2 is 4. 4 times 3 is 12, times 2 is 24. Simplify that to 1/6. Man 1 draws the treatment. He had a 50-50 shot. I'll start writing 1/2 now. Man 2 draws control. That means there were 2 controls left after man 1, and there were 3 total from that. 3 total chips that he had to choose from. Woman 1 now draws. She gets control, and there was 1 control left, and there was 2 that she had to choose from. So just like before, this would be 1/6. Go ahead, pause, see if you can figure out the next 2. All right, you should kind of notice that these are all going to be 1/6. So if you read BII for the chip method, what's the probability that man 1 and man 2 are in the same group? Again, probability of A plus probability of D. 1/6 plus 1/6 is